Welcome to another deep dive. Today, we're tackling a truly massive question, and I mean that literally. What is the absolute brightest thing in the universe? We'll be exploring a fascinating mix of sources you sent over.
It's going to be a wild ride, that's for sure. And you even included something about the yin-yang symbol, which might seem a little out of place, but I promise it'll all connect in a way that might surprise you.
All right, color me intrigued. So where do we even begin with a question this big?
Hmm.
I mean, my desk lamp is pretty bright when I'm up late working, but I have a feeling that's not what we're talking about here.
You're right. We're not just talking about what appears brightest to us from Earth. It's easy to be fooled by distance. For example, a 100-watt light bulb might seem brighter than the sun if you held it close enough to your face. But that's all about perspective. In terms of sheer energy output, the sun is septillions of times brighter.
Septillions, okay, that's officially a lot of zeros. So how do astronomers even wrap their heads around measuring brightness on a cosmic scale?
Well, they use something called absolute magnitude. It's a way to level the playing field by comparing the brightness of objects as if they were all at a standard distance. Think of it like judging the strength of different light bulbs by lining them up 10 feet away and seeing which one illuminates the room the most.
That makes sense.
Hmm.
So using this absolute magnitude, what are some of the contenders for the brightest thing in the universe?
Well, we have AE to start with stars, and not just ANY star. We're talking about R136A1, a star SO, massive and luminous. It makes our sun look like a tiny speck of dust.
So how much brighter are we talking? Like 2 times brighter? 10 times?
Oh, much more than that. R136A1 is about 8.7 million times brighter than the sun. It's also about 256 times more massive.
Whoa. That's just incomprehensible. I mean, if our sun were that big, wouldn't it just engulf the Earth?
Well, probably. But what's fascinating about stars like R136A1 is that they live fast and die young. Their immense size means they burn through their nuclear fuel at an incredible rate, leading to much shorter lifespans than stars like our sun.
So it's a trade-off. Incredible brightness, but a fleeting existence. Makes me think about how even the most brilliant things can be ephemeral.
Absolutely. And speaking of fleeting brilliance, we have to talk about some of the most explosive events in the universe. Supernovae. Specifically, we're going to focus on a type called hypernovae, which produce incredibly powerful bursts of gamma rays.
Gamma rays. Those are the things that can turn you into a superhero. Or give you superpowers.
Right.
Not sure which.
Well, they can certainly do a lot of damage. Gamma ray bursts, or GRBs, are considered the brightest electromagnetic events in the universe. They can release as much energy in a few seconds as our sun will produce over its entire 10 billion year lifespan.
Okay, that puts things into perspective. Suddenly, my desk lamp seems a lot less impressive.
To give you an idea of the potential power, there's a star system called WR104 about 8,000 light years away. It's a candidate for producing a GRB. And some scientists believe that if a burst from WR104 were to hit Earth directly, it could deplete a significant portion of our ozone layer, leading to a mass extinction event.
Okay, now that's scary. But 8,000 light years? That seems pretty far. Like, really far.
It is a vast distance, but it highlights the sheer power of these events. Even from thousands of light years away, a GRB could have a devastating impact.
So we've got megastars and explosive bursts of energy. What else is vying for the title of brightest?
Well, this might surprise you, but one of the strongest contenders comes from one of the darkest things in the universe: black holes.
Wait, black holes. Aren't they famous for swallowing light and not emitting it? How can they be bright?
That's a great question, and it leads us to one of the most fascinating paradoxes in astrophysics. While it's true that nothing, not even light, can escape a black hole's event horizon, the region around a black hole can be incredibly luminous.
Okay, I'm officially hooked. Explain this cosmic magic.
It all comes down to what happens when a black hole devours matter like a nearby star. That material doesn't just fall straight in. Instead, it spirals inward, forming a swirling disk of superheated gas and dust called an accretion disk.
An accretion disk. It sounds kind of like a cosmic whirlpool.
That's a good analogy. And as this material in the accretion disk swirls around the black hole at incredible speeds, friction heats it up to millions of degrees. This superheated matter emits an unbelievable amount of radiation, including visible light, making the region around the black hole shine incredibly brightly.
So it's not the black hole itself that's bright, but the material being sucked into it. Kind of like how a light bulb's filament glows because of the electricity flowing through it.
You got it. It's a mind-bending concept, isn't it? The darkest objects in the universe can power some of the brightest phenomena we've ever observed.
All right, this is already blowing my mind. But I have a feeling we're just getting started. What happens when you take this black hole-powered brightness and crank it up to 11?
That's a great question. And it leads us to our next contender, quasars.
Quasars.
Quasars. The name sounds like something out of a sci-fi movie. What are they exactly? Imagine a black hole, but supersized. A supermassive black hole. Millions or even billions of times more massive than our sun. Now picture that black hole at the heart of a galaxy with an accretion disk so large and energetic that it outshines all the stars in that galaxy combined. That's a quasar.
So it's like a black hole on steroids, powering a galaxy-sized spotlight.
That's a pretty good way to put it. Quasars are some of the most distant and luminous objects we've ever detected. One example is quasar 3C 273, about 2.4 billion light-years away. Despite that distance, it shines brighter than 1 trillion suns.
1 trillion suns. That's more stars than I can even imagine. And we're seeing this light from 2.4 billion years ago. That's like looking back in time to when Earth was still forming.
Exactly. It's mind-boggling to think that the light from these quasars has been traveling across the universe for billions of years, and we're just now capturing it with our telescopes.
So if these supermassive black holes are powering quasars, does that mean there's a chance our own Milky Way galaxy could have a quasar lurking at its center?
Actually, most galaxies, including our own, have a supermassive black hole at their center. But not all of them are actively feeding and creating quasars. You see, quasars need a lot of fuel, meaning gas and dust, to power their incredible luminosity.
So our Milky Way's black hole is just taking a little nap right now, maybe saving its appetite for a cosmic feast later on.
Well, there might be a feast in its future. Remember how we talked about the Andromeda Galaxy colliding with the Milky Way in a few billion years? That collision could send a huge amount of gas and stars swirling towards the supermassive black holes at the center of each galaxy.
Ah, so it's like a cosmic potluck for hungry black holes. Could that trigger the formation of a new quasar right here in our galactic neighborhood?
It's definitely a possibility, and if it happens, it would be one of the most spectacular astronomical events imaginable. We'd see a brilliant beacon of light shining from the center of our galaxy, visible for millions of light years in every direction.
Wow, that would be incredible. It makes you wonder what other cosmic events are unfolding right now, far beyond our current view.
It's humbling, isn't it, knowing that we're just a small part of a universe filled with such vast and powerful forces. And it's not just about distant galaxies. Even here on Earth, the way we interact with light can have profound effects.
You're talking about light pollution, right? One of the sources you sent me talked about how our brightly lit cities are actually obscuring our view of the night sky.
Exactly. The article featured the work of artist Thierry Cohen, who created a series of images imagining major cities like New York and Paris plunged into darkness, revealing the Milky Way blazing overhead. It's a striking visual reminder of how much we're missing out on because of light pollution.
I've seen those images, and they're absolutely breathtaking. It's kind of sad to think that many people have never seen the Milky Way because of the constant glow of city lights. It reminds me of that story about the 1994 earthquake in Los Angeles.
The one where people called 911 because they saw the Milky Way during the blackout and thought it was something strange.
Yes. It's amazing to me that something so fundamental to our universe, our own galaxy, can seem so alien to us because we've lost sight of the natural darkness.
It really highlights the importance of protecting our dark skies. By reducing light pollution, we can not only improve our ability to observe the universe, but also reconnect with a sense of wonder and awe that has inspired humanity for millennia.
It makes you think about the balance between light and darkness, and how they both play a crucial role in our understanding of the universe. Which brings us back to that yin-yang symbol you mentioned earlier.
Right. It's interesting, isn't it? We started this deep dive looking for the brightest thing in the universe, and we ended up talking about the importance of darkness.
It's like the yin-yang, the interconnectedness of opposites. We wouldn't be able to appreciate the brilliance of stars and galaxies without the contrast of darkness. And even the darkest things like black holes can fuel the most luminous phenomena.
It's a beautiful paradox, and it speaks to the complex and often counterintuitive nature of the universe.
So after all this, after exploring stars, supernovae, black holes, and quasars, which one comes out on top as the brightest thing in the universe?
Well, it's a bit of a tricky question. In terms of absolute magnitude, the current record holder is a blazar, a type of quasar with its jets of energy pointed directly at Earth. The brightest one we've observed is called 3C 454.3, and it reached an absolute magnitude of -31.4. To put that in perspective, that's billions of times brighter than our sun.
Blazars. That's a new one for me.
Hmm.
But it sounds intense. So essentially, we're talking about the most powerful beams of energy in the universe, generated by supermassive black holes billions of light years away.
You got it. And it's a reminder that there's still so much we don't know about the universe. Every new discovery pushes the boundaries of our understanding and opens up new avenues for exploration.
It makes you wonder if there's a limit to how bright something can be. Is there a cosmic ceiling for brightness? Or could we someday discover something even more luminous than these blazars?
That's a fantastic question. And it leads us into some truly mind-bending territory. That's a
Hmm.
fantastic question. And it leads us into some truly mind-bending territory. Is there some kind of cosmic speed limit for brightness? Like, can a star or a quasar just keep getting brighter and brighter forever?
Yeah, like is there some kind of upper limit? Like can it just go on infinitely?
That's where things get really interesting. As far as we know, there are limits imposed by the laws of physics. For example, if an object becomes too massive and too bright, its own gravity could cause it to collapse or even tear itself apart.
So it's like a cosmic balancing act between gravity and energy.
Exactly. And there are some truly wild theories out there about objects that push these limits to the extreme. Have you ever heard of a Kugelblitz?
A Kugelblitz. It sounds like something you'd order at a German bakery.
It does sound a bit like a pastry, doesn't it?
Yeah.
But it's actually a theoretical object predicted by Einstein's theory of general relativity. Essentially, it's a black hole formed not from collapsing matter, but from pure concentrated energy, like light.
Wait, a black hole made of light. So if I point a flashlight at a wall for long enough, could I theoretically create a black hole in my living room?
Well, not quite. The amount of energy required to create a Kugelblitz is astronomical, literally. We're talking about focusing an unimaginable amount of radiation into a tiny space.
Okay, so it's safe to say my flashlight isn't going to cause any cosmic catastrophes anytime soon. But it is mind-blowing to think that something as seemingly intangible as light could have enough gravitational pull to create a black hole. It really makes you question what we think we know about the universe.
It's a good reminder that we're always learning and discovering new things. Who knows what other mind-bending phenomena are out there just waiting to be unveiled?
Well, I, for one, am definitely feeling a renewed sense of wonder and curiosity after our deep dive today. From giant stars to explosive gamma-ray bursts from black holes that power quasars. To the possibility of black holes made of light, it's been an incredible journey.
It's amazing how exploring the question of what's the brightest thing in the universe led us to so many other fascinating concepts.
It really highlights how interconnected everything is in the cosmos. Light and darkness, matter and energy creation and destruction. It's all part of this intricate dance that's been playing out for billions of years.
And that's what makes astronomy so captivating. It's not just about collecting data and crunching numbers. It's about grappling with the biggest questions about our existence, our place in the universe, and the fundamental forces that shape reality.
Well said. So for all of you listening out there, the next time you gaze up at the night sky, try to see beyond the twinkling stars. Imagine the incredible journeys those photons of light have taken, traveling for millions or even billions of years to reach your eyes. Think about the cosmic furnaces at the heart of distant galaxies, churning out energy on a scale that defies comprehension. And remember, even in the darkest corners of the universe, there's always something brilliant waiting to be discovered.
Keep exploring, keep questioning, and keep looking up. You never know what wonders you might find.
And that brings us to the end of our deep dive for today. Thanks for joining us on this cosmic adventure.